There we go. We are recording, I believe. Where does it say? Oh yeah, it's like doing that thing down there. Okay. All right. Okay. So you guys can see all this, right? Okay. Right. You see my like home page and all that nonsense. All right. I want to go back. Get rid of some of this clutter here. We don't really need this. We don't really need that. We don't really need that. Okay. I want to go back and go over something that we did last time that I don't think I was as clear on as I wanted to be. And I also changed one of the patches that I put into the archive for people to use, okay? And it's going to be important because we're going to use it today, so that's why I want to go through it, okay? It has to do with the way that we get information into RTcmix, okay? So let me start this up. Zoom people, can you see my screen?
Yes.
Okay. Yeah, for some reason it kind of went away weirdly, and I was afraid that I'd done something to it. Okay. All right, so good. All right. So here comes Max. Oh, it's opening it up in 7. That's okay. We were using 8 last time, but it doesn't really matter. Okay. Recover edits. Yes. Yeah, I had some weird crashes this afternoon. Hope I won't have them here. Okay. This is not the one I want. This is the one I want. Okay. All right, now, this is the one. Is that big enough for everybody? Can you all see it, the Zoomers? Is that okay? Okay, good.
Yes.
All right.
Yep.
Now, this is the one where we set the low frequency and the high frequency constraints of our random number thing from outside variables. And those outside variables are $1 and $2, okay? So when this script executes, it looks at what the current value of those variables are, okay? And what I did was before I had that weird message box, okay? But I think this makes more sense, you know. When I set a number here, okay, what's going to happen is this prepend is going to add var1 to the front of that number. So in fact, if I print it out, just to show you how this works, okay. Now, when I do the print, it's going to show up here in this Max console thing. Okay, so let me move that over here. Okay. Now, watch what happens when I change this number. See, it says var1. Okay. And this one, it would say var2, and then whatever the number was. Okay. I want to explain a little bit about this mechanism. RTcmix. Notice that I have all kinds of different things coming into this kind of inlet here that they call it. I have numbers, I have bangs. In the future, I might have other things coming in. RTcmix looks for a message type. And in this case, it's looking for the message type var. Okay? When it sees var, it says, oh, it's going to be one of my variables. And it's going to be the first one. That's the number it's going to be. So it sets $1 to that number. And over here, when it sees something coming in, oh, it's a var message. I'm going to set a variable. It's going to be $2. And I set it there.
Okay. Are you recording?
Yes. Okay. Yeah. Yeah. That's. I wanted to record because I know this isn't documented really anywhere else. Okay. I did find from one of our grad students there's a pretty good sort of tutorial thing for Max MSP, and I will link that into this class today. So people who are new to this, you know, they can kind of take a look at it and see what happens. Okay. So I wanted to make sure that that was kind of going through it, okay? And the other thing...
To clarify, what
Sure.
is the advantage of using prepend versus the way we did it before?
No advantage at all.
There,
I just thought this was pedagogically clear.
yes, okay, cool.
Because what we did before was we had this weird thing, and I didn't even explain what it is. Max has these message boxes. We're going to use those a little bit today, okay? But they're different from these, and I didn't even explain what it was. It said var1, $1, and I thought, oh, this is confusing. Yeah, so that's why this is all changed, okay? All right, now, the thing to realize about this is it has to do with, at the very beginning of the class, I said Max was a scheduled language, okay? And this has to do with when variables get set, all right? And right now, if I run this, okay, it's going to do this kind of random strum thing. And notice that I'm generating 2 notes, and then I'm banging the script again. So that's going to give me the ability. I'm going to start this up now. Let me set my high frequency up here to something reasonable, okay? Okay, no, let me. Okay, quick question. Can the Zoom people hear that okay?
Yes.
Did you? Okay, good. Okay. Okay. So if I change this, okay, say I make this be 1 to 65, and then I'm going to make it be 2000, I hit return now. Notice when I hit return now, it happened very quickly, okay? That's because I'm only generating 2 notes at a go. Let's generate 20 notes at a go, okay? Which will still work fine, okay? Let me start out this, I'll bring this back down to say 165 here, okay? And I'll start it out. Okay. Now, let me go up to 2000, go. Notice the delay? That's because those variables only get set when the script executes. So this script had to wait for all those 20 notes to go before it then executed again. Okay, so this has to do with how interactive something is going to be. Well, what's the advantage of scheduling more than 1 note? Why don't we just do 1 note, okay? It has to do with the efficiency and how the computer kind of responds. Scheduling something to execute is relatively efficient compared to setting it up and executing it all the time. And even right off the bat, setting this, setting the start, unrolling the loop, and all that nonsense, you do that every time you execute the script. And when we start adding envelopes and things like that, you do that every time you execute the script. So a lot of times, it's better if you can schedule a group of notes at a time, because it does, today's machines are so fast, it's not a big deal. But when you start embedding these in environments like Unity or something like that does use a lot of your CPU, this can make a difference. Okay, I'm going to leave this at 2 because that's a pretty reasonable amount. A lot of times I use 4, and you don't notice the latency that much. Okay, but again, I just wanted to make sure that you kind of appreciated what that is. And in fact, the next thing I want to show you is how you can affect a note that's actually executed. Right now we can only affect a note when it gets scheduled to execute with this mechanism. RTcmix has another mechanism to allow you to go in and affect a note as it's executing. And let's set that up, okay? And I'm going to review a few things that we did last time. And then we're going to start actually sonifying some data. Whoa, that'll be fun. You guys can't see Vinay on Zoom, unfortunately, but he's like rocking and rolling. Okay. All right, so let's quit this guy, okay? And let's go to week 3, and I'll just use max 7. It doesn't really matter. Okay, so I'm going to start up a new max patcher, okay? And in this patcher, I'm going to do my favorite patch, RTcmix tilde with 2, okay? And I'm going to add 1 more parameter, okay? Oh, Steve noticed. Steve's been great. He's been our kind of guinea pig. But I meant to play your Beethoven at the beginning of the class. We'll do it at the end if I can remember, okay? But yeah, he kind of suffered through and did like a remarkable thing, okay? Unfortunately, what he had done was this.
Yeah, that didn't work.
Yeah, and it was looking for an object called RTcmix tilde 2, whereas we wanted to do that. I'm adding 1 other parameter, again with a space there, and it's going to change the top of this, okay? And we're going to use that thing, all right? Notice now that instead of just 2 of these here, it has 3. It has 1 input for sound, 2 an input for sound, which we're not using right now at all, and then it has 1 other one, and that's why if I had said 2 there, it would have 2 other ones. If I said 3, it would have 3 other ones, okay? We're going to use that. And we already know the outputs are left channel out, right channel out of sound, and then other stuff that comes out. So let's go ahead and finish this, okay? Let's put in, say, our easy DAC, okay? Click this guy here, click this guy here, put our bang up here, click this guy here, okay? And let me save this now, okay? Save, we'll say save, yeah. And we're going to go to data sonification week 3, and we'll call this, what do I call this? Oh, I know, my brain is shutting down when I can't even think of
What was the third object you did?
The third,
The one with the circle?
The vent.
Oh, yeah, it's a bang. Yeah, that's the thing that triggers the script. Yeah, sorry about that. Yeah, okay. We'll call this, yeah, real time change one dot set. Okay? All right. So here's what I want to do. I want to make a note using that wave table instrument, okay? All right, and let me go out to my documentation, and we'll go to the new RTcmix docs. This is the rtcmix.org. We'll go to instruments, and just to refresh ourselves, we'll go down here to synthesis, and we'll grab wavetable, and I will simply copy the whole thing out, paste it in here as a comment so that we can see what we're dealing with. And first things first, let's just make a sound with it, okay? It's always good to just make sure you're getting sound right off of that. So our output skip is going to be 0. Our jur, let's set that as a variable. We'll say jur equals, say, let's say 10 seconds, okay? Oh no, let's say 20 seconds, okay? Because I want to show you stuff, okay? Amplitude, let's set our amplitude as a variable too, okay? We'll say amp equals 20,000. And again, that's because of that weird 2 to the 16th nonsense, 16-bit stuff. Notice that it does differentiate between uppercase and lowercase, and these variables that are listed in the documentation as uppercase have a very specific feature to them, and that's what we're going to look at right now, okay? For pitch, let's say frequency, okay, freq, and we'll just set that to be, say, 379 hertz, okay? 379. Our pan, we want to go in the middle, so we'll say 0.5, you know. And wavetable we're not going to use. It's an optional variable. Notice it's within those square brackets, so we'll maybe use that later on, okay? So this should work. Let's make sure it does, okay? Let's go out here and I'll save it. And now I'll turn on our thing. And be prepared if you have headphones on because it's going to be... Okay. And that'll go for 20 seconds, all right?
Now, when you save it, is it saving the script inside of the Max file?
Yes.
Or do you have to save it separately?
No. You can save it separately, but this is all part. When you open up a patcher, all the stuff should be inside the RTcmix object. Yeah, good question. All right. First of all, it's annoying. It's a little bit loud. Oh, it's way too loud. I thought it sounded like a weirdly distorted sine wave. Okay. Yeah. Let's tone this down a little bit. Let's make it be 10,000. Okay, and not 100,000. Yeah, that was it.
Can you use scientific notation, like 2e4?
No.
No? Okay.
Yeah. You know what? I'm not sure about that. I don't think so. I'd have to ask Doug Scott.
Okay.
Yeah. All right. Now we should hear a nicer sine wave. Yeah. That's what it's supposed to sound like. Okay. All right. Not like that. Okay. Now, it turns on and off abruptly. Okay. This is where I'm going to use an amplitude envelope. Okay. I'm going to say amp end equals. And the thing I'm going to use, we talked about at the end of the class last time, is this make table. Okay.
How do you pull the script window up again?
Oh, what you do is make sure it's locked, okay, and then double click on the RTcmix object. Right. Okay.
Sorry, I got a question.
Sure.
Because in the function it says pitch and pan wavetable, so why would you just use frequency and the last two variables?
Yes. Oh, I meant to. Sorry. Yes. Yeah. That would have.
I mean, in the function, the first line it says pitch, and behind it includes pan and wavetable.
Yes.
So what's the relation between the actual function we're using and
Okay. Remember, these could be either variables, or you can just type the number in directly. Okay. Is that what you're asking, Scott?
Yeah. So the frequency and the 0.5 means pitch.
No. This pitch is there. Notice that there's a comma right there, okay? But it's inside these. This means when you see the square brackets, those are optional variables. You don't have to specify them,
Oh.
okay? I'm going ahead and I'm putting a comma after frequency, which is our pitch, And I'm putting 0.5 in for the pan because the default would be 0.
Okay.
And in a stereo, that would just put it in the left channel. And if you have headphones on, especially, it makes you go like this, you know. So I put in 0.5. The wavetable, the default is a sine wave, and I'm happy with that. I'm not going to override that yet. Okay. Yeah. All right. Okay. But this amp end, okay, 2, 1, let's say 10, 1, we'll say 9, 1, 10, 0. Okay, what did I do here? Okay, I don't think I did a good job of explaining this last time. This make table thing, I'm going to show you the documentation, is a very complicated function. It does a lot of things, okay? The thing it does is what you put in quotes here, okay? And you can create waveforms, you can create different kinds of shapes and stuff like this. And what I'm creating with it is called a line, okay? Then this number, just ignore it, just always put in 1,000 there. I'm not even going to explain it right now. And then the next bunch of numbers have to do with what you've selected here. When I say line, it means I'm going to give it a time and then a value, then a time and then a value, then a time and then a value, and then a time and value. So at time 0, this will be a value 0. At time 2, it'll be 1. What it will do is draw a line, figuratively, between that 0 and that 1. So for 2 seconds, it'll go up to 1 if we have a 10-second long note. Then up to 9 seconds, it'll stay at that 1 because at 9 it's still 1. Then at 10 seconds, it'll go down to 0. So we basically created a shape that goes up and down, and that'll be our fade up and our fade down. Now, that'll be exactly 2 seconds and 9 seconds and 10 seconds if the duration is 10 seconds. If the duration is 20 seconds, what it's going to do is stretch that out. So it'll actually be 0, take 4 seconds to get up to 1. And then 9, it'll be 8 seconds to get back down. Okay? No, it'll be 18 seconds. Yeah, 18 seconds. So this will compress. You can use a relative. I often use a 0, 0, and then 20. I use a scale of 100. It's like a percentage of the thing. It's very easy to think of it that way. Okay. Now to get this to actually do the fade up and fade down, we need to multiply it by our amp. Okay. And that's because it will deliver these numbers. And you start out with 0 times 10,000 will be 0. Then you go up to, at time 2, or relative time 2, 1 times 10,000. It will go from 0 to 10,000. So that'll give our nice amplitude fade up, and then our amplitude fade down. Okay, if this is a little weird, just copy it and use it. This is one of the weirdest concepts that we're going to introduce so far. Okay, so don't get too freaked out by it. All right. Okay, but now if I play this, I'll save it. Here's a nice fade up, and then in 20 seconds you'll hear a nice fade down. But I'm not going to wait that long because I'm impatient. Okay. All right. Cool. All right. So that's basically this wavetable stuff. All right. Now, let me show you just for fun the documentation for wavetable. That's not an instrument. That's going to be a score file command. Okay.
So a
And-
good question.
Sure.
Is that a DSR envelope?
It can be. You can actually do ADSR. Basically, is a thing that sets up an attack, then an initial decay, then a sustained, then a release. You can actually duplicate that by putting the numbers in. However, with this, you can get much fancier than that. You can have it fade up, fade down a little bit, fade back up a little bit, fade down a lot, fade up, fade down. You can do any
So
number.
it's more than 4 phases.
Yes, yes. You can have as many phases as you want. Okay,
Oh, so the parameters can just keep going and going?
as many as you want. I think there's an upper limit of like 32, 768 or something. I can't remember what it was, but there's a lot. Okay. Okay, down here. So general. Okay. You see all these things that a lot of them don't even matter. We don't care about them. These are going to be important later. These are going to be important as we start talking about how we represent pitch. Random numbers, we already looked at IRAM, okay? Envelope control. That thing, that's an envelope, we call it, okay? Here's make table. These are all the different things that make table can do. okay? And notice that we've been using line. So it gives you the documentation, you know, line, then 1,000, time 1, value 1, time n minus 1, value n minus 1, time n, value n, you know, that gives you that nice however many curves you want, okay? All right, so we're cool with that. Now, like I said, the point of this was to kind of show you how you can control things dynamically in real time and not have to wait for it to be scheduled or wait until after the scheduled thing reflects it. These variables that are in capital letters, they're special. They're what we call P-field variables, okay? And the name comes from like 1985, okay? It has to do with positional field or positional parameter. You don't need to know that. It's just old history, you know. What this means is that there's a way that you can actually set that variable up to be controlled as the node is executed, okay? And here's what you do. Instead of saying the frequency is going to be a number, I'm going to say the frequency is going to be make connection. I'm going to connect it to 1. And no, make connection, sorry. What did I do? Well, I'm saying that I'm going to get my number for the frequency from an inlet. That thing is called an inlet. And the inlet I'm going to get it from is inlet number 1, and that's after the 2 sound things, okay? That's inlet number 1. That's when I typed that one there, that's when that guy appeared. And this final thing is the initial value, okay? So, if I executed it now, it would play, okay? Because it would just take that initial value and play it. But here's the fun thing you can do. You can take a number box. A lot of times I use sliders, but I'm not this time because I just want to be kind of straightforward. And connect it to that. All right? And now, if I hit play, it'll start out at that 379. If I change this, ooh, isn't that fun? Yeah. Okay. So you can change it dynamically. Okay? Now, it will only happen when this node is executed. Okay? If I say, let's say the start time for this is going to be 5 seconds from when I hit the bang. Okay? All right, and I'm going to save this. Okay? Hit this guy. Hey, nothing's happening. Nothing's happening. Nothing's happening. But 5 seconds in, here it comes. Obviously. Okay? So this is kind of like the mirror image of the variable thing, where it's only set when you schedule it. This only gets set when you execute it. Okay? If that makes sense. All right. Now, I'll be honest, I don't think we're going to use this feature as much in data sonification as we will the scheduling thing, because our data that we're going to be looking at a lot of times is going to come in little discrete numbers, you know. And I mean, we can do it. Yeah. Well, I shouldn't say that. Yeah, we'll come up with some cool ways of doing things. All right. All right. So, speaking of data and fun things you can do, let me close this off now. Okay, I think I saved it. Yeah, let me go back here. Set that back to 0 and I'll save it so you can download it. That should be good. Okay. Now, some of you guys may have seen this. This is kind of a famous equation, okay? And what's remarkable about it is how simple it is, okay? And let me bring this up, okay? And I just want to write down this equation. I should have, like, done it already. Yeah, here we go. Create, okay. Okay, all right, now, let's go here, okay? And the equation is x. Ooh, it's red. Put n minus 1.
Does everybody know about graphic converter? It's my favorite.
Oh, yeah.
Okay.
Oh, good Lord. Yeah, this I use this for almost everything.
Yeah.
Like showing you equations, okay? Oh, no, that's not right. I'm already screwing up. X sub n equals x. Oops, let me get that up there a little bit. X sub n minus 1 times, oops, I'm not doing very good with this. Okay, times r times 1.0 minus x.
This looks super familiar.
It is very familiar, okay? You're going to be amazed at what this does. Okay. What does all this mean, okay? This is one of the most famous equations of chaos theory, okay? It's called the logistic map, or the population equation, because it's also something that they use to kind of model predator-prey relationships and everything. And what's remarkable is how simple it is, and how amazingly complicated the output is that we're going to experience. And we're going to sonify it in graphics. Whoa! All right. Here's what it does. Okay, this, at the heart of a lot of chaotic equations, is this notion of iteration, where you do something over and over and over again. And what you do is you have to give it an initial value of x, like you might say up here, x equals 0.5. Okay. And you put that in for this x sub n minus 1, and then you choose a value of r, and I'll talk about that in a second, and then you put the x sub n minus 1 over here again. Then you simply just do this equation. 0.5, if r is like 2, multiply 2 times 1.0 minus 0.5, and you get some value. That becomes x sub n. Then you go back and substitute that value in for those ones, run the equation again, get another x sub n. Then you go back and put that one in for those. And you do this over and over and over again, okay? And the trick is, you've got to do it about 1,000 times before you get like a stable output from the equation, okay? And let's just take a look at it first of all, okay? And we're gonna look at max MSP, and this is a good way to kind of like figure out, when we start looking at data coming from sources that we're not quite sure what the constraints are, it's good to take a look at it and see what your parameters are. So let's put this guy away. And let's go back to max MSP, and we'll start up that thing here. And I'm going to say RTcmix, and I'm just going to say 2. We don't need any special inlets or anything like that on here. Type D for bang. By the way, one of the things I'm doing that's not so great is I'm using keyboard accelerators. You know, all those objects that I'm typing in, they're all available up here. Like I could take this and drag it down, okay? I should have shown you that earlier on, but I didn't because I'm an idiot. Okay, but I'm basically saying like M will type me up a new object, and then I can type in the object name, like EZDAC, tilde, and then I'll connect it up, okay? Actually, we don't want to connect it up right now, okay? Because we're not going to actually look, we just want to look at the data, okay? We want to see what's coming out of this thing, all right? And to do that, first of all, consult my stuff here, yeah. We're going to open up and we're going to put in the equation here, okay? And we're going to set R out here, okay? I'm going to use a floating point number box. Now, Nicola showed us last time that you can go over here and you can actually set the display format for this kind of box, but there's a shortcut to do it. If I type I get an integer box. If I type F, I get a floating point box. You guys all know the difference between integers and floating points? Okay. In computers, we're not doing this in RTcmix because we don't have to type what they call types of variables. But in computers, there's 2 different kinds of numbers. Well, there's more than 2, but mainly 2. Integers have no decimal point. Floating points have a decimal point. That's the only difference. I happen to know that this R thing, we're going to want to use some decimal point values in it, okay? So let's take that, and let's get it sent into our thing. We'll just say prepend. Whoa, what did I do there? Good Lord. M. Nope, not that. Prepend var1, okay? So we're going to make this be var1. We'll send it in here. Okay, and we'll go in here, and we'll let that be R equals $1. Okay? So we got our R. We're going to get our X from somewhere else, but let's go ahead and put in the equation. And like I said, we have to iterate it a bunch of times. So let's go ahead and do this. We'll say for I equals 0, I is less than 1,000. That's happened so quickly. It's amazing, okay? I equals I plus 1. And what are we going to do? We're going to say X equals R times X times 1.0 minus X. That's all there is to it. Isn't that great? Okay. Now,
Isn't it I
I think it's
equals?
I equals I. In the
oh yeah,
program.
it is. We see the minus key is real close to the equals key. That's, yeah. I hate iPhone keyboards because I always type the wrong key. Like, every time I type the word and, it comes in as SND. Because I use that. It's a sound file.
Yeah.
Oh my God. Well, let's spell check and we have fun together. Okay, so now I want to see what's going to come out of this equation because that's going to give me a clue as to how I'm going to sonify it, map it onto sonic parameters, and I'm also going to use as clues how I'm going to visualize it, map it onto graphic parameters. So let's just print out 4 values here, okay? For I equals 0, I is less than 4, I equals I plus 1, okay? And we'll take our equation and we'll run it. And then let's just print out the value of X before we run it again, okay? Because remember, oh, I did that wrong. Remember, it'll do everything inside these curly braces. So we'll do the equation, print X, do the equation again, print X, so we'll get values out. Okay, we'll be able to see them, all right? Let's run this guy, all right? Now, we have to do a couple things. We already have an R thing up here, right? Okay? In fact, just for fun, maybe I can label that with a comment. I can say R. There we go. Well, that's pretty cryptic, isn't it? Yeah. Okay, let's save this guy, okay? We're going to call this chaos 1. Now, the thing I'm missing, remember I have to have an initial value for X. If it sees this equation and I haven't told it what X is yet, it doesn't know what to do. And it's going to go, I don't know what to do. So what we're going to do is we're going to create a message, okay? Now, everything we've done has been either these number boxes or like a button or something like that, or these objects. Max MSP also allows you to create a message, not an object, but a message. And I can also do it by typing M. And I'm going to say this message contains text. And the text is going to be X equals 0.5. So now, when I send that into RTcmix, if RTcmix sees it's a text thing, not a var1 thing or anything like that, it'll say, oh, it's a text. I'm just going to like interpret that as if it were part of my score. So if I click this first, that will set the initial value for this X, and I can compute it, okay?
So whatever is written in the message runs before anything that happens inside.
Well, if I click it,
Okay. If you click the message.
Yeah, I'll click the message before I click the bang.
Oh, so
Okay.
the message will get run whenever you click it. Okay.
Okay, well, let's try it out. Now, the other thing that I haven't told you is for RTcmix to work, Steve actually discovered this, you know, for RTcmix to work, period, you have to turn on the audio, okay? If I try to do this now, it'll say, oh, no, that must be on. You know, nothing has happened here. Life is bad, you know? So we have to turn this on. And let's initially set R to be 2.0, okay? Maybe I know something that you guys don't, okay? All right, now, so I've got my thing turned on. I'm ready to run it. Let me send in this. I can send it in a bunch of times if I want by clicking on that. And now, watch over here, and you'll see the values of X being printed out in this console area, okay? So there we go. Starts out with X being 2.5. Now, let me start increasing R. Oh, gosh, I forgot. Yeah, can anybody tell me what I did wrong?
Nothing.
the sound thing to the.
No, no, we're not making any sound yet. I clicked the bang once. It executed once. Then what happened? I need to have a max bang come out and re-trigger it. I only generated 4 values. Then it said, all right, that's all you wanted me to do, right?
How do you make the numbers go up and down so fast? Is that an alpha or in the number bunch?
I'm sorry. I didn't explain that either. I'm using my mouse. If I click here and I move my mouse up or down, okay, I can type the numbers in directly. Yeah, okay. Yeah, and if I click on the outside one, it goes like that. Okay. If I click on this one, it'll go like that. If I click over here, it'll go like that. Okay. That's just a way of like being able to do it. Like I said, a lot of times you can bring down these sliders in Max MSP. I decided not to because I just want to keep this kind of clean for what we're doing. But we need to, yeah, I forgot to go down in my notes one further thing. We need to say, after it's done printing 4 things, we're going to have to send out another bang, okay? And let's send it out 0.2 of a second from now. So we'll have a little bit of time to kind of see what these numbers are, okay? So now, I'll connect that. Oh, this is the fun part, to this. So now, when I set it off, it'll do it over and over and over again, and not just generate 4 numbers and stop, okay? And as I change R, then it'll change. So let me set this up, hit text, okay? Here we go, bang, all right? Yeah, and as I increase this, notice that our numbers are increasing over here. That's kind of fun, okay? Increase a little bit more. Notice our numbers. Now, the thing to notice that our numbers are all less than 1, okay? That's one of the things we're looking for, is what is the range of these numbers, okay? And if, in fact, I take this down to even below 2, if I, oh, shit, I went too far. Oh, good. Okay, I didn't blitz it out. If I go down to 0, it will actually stop the equation, because it'll just start generating zeros, you know, because x will be 0, and it's multiplying zeros by zeros all the time. But we're going to go up here, and something really bizarre is going to happen a little bit, okay? It's already starting to happen. Notice that now it's not just putting out a single number, it's oscillating between 2, 0.57 blah, 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 and 0.749, 0.57, 0.749, okay? So once we hit about 3, it started doing this weird thing, okay? And now as we go up, it's still doing between 2 numbers, but now they're getting farther apart, 0.49 and 0.8, okay? Well, let's keep on going, all right?
Is R random?
What's that?
R means random?
No, R is
Range.
just the name of the number. It's called, for some reason, the people who invented the equation said, we're going to call that number R, okay? It means, I don't know what it means. Ratio or something. Or, yeah.
Greater than 2, so
Yeah.
or
Right, stands for really cool. Yeah, but it's not random. We're actually setting it by hand here, okay? So it's our number. We're going to get it up. Oh, look. All right, now, here we go. Now, something very odd is going to start happening. Okay, it's splitting. Oh, no, I'm not far enough. Sorry. Notice I'm being very careful about this. We're going to sneak up on, okay, still 2 values. Now, whoa, look.
It's stable.
Now it's actually doing 0.455, 0.846, 0.424, 0.843, 0.455, 0.856. It's doing 4 values, okay? But then if I go even further, it starts going into, chaos, It starts generating chaotic values. At this point, you can't predict what the values are going to be. That's the fun part about this equation. Once you get above 3.6, it just kind of goes berserk. And again, notice they're all between 0 and 1. That's the main thing to notice here, okay? Now, something else. Like I said, if I go to 0, I'll destroy the equation. If I go above 4, it will destroy the equation too, okay? Let me get it up there, okay? But look at that. That's just, those numbers are berserk. They're crazy numbers, all right? Go up here and we go to, oh, infinity, oh, we fall off the map, okay? At that point, it's not computing, okay? So once R hits, R cannot go above 3.99999. Once it hits 4, it's going to destroy the equation. So these are the things that we wanted to kind of learn and find out about, all right? Because we're going to use that now to make sound with it, all right? So we're going to leave all this infrastructure in place, and now we're going to hook up the sound.
Brad,
Yes.
I thought maybe, can you say a little bit more about why this oscillating behavior comes up?
I can,
I
you
mean,
know,
why does it make this jump from 2 to 4 to many values, and why is 3.999 the border?
okay, Nicola, let's wait until I get the full thing up with the graph,
Okay.
because it's easier to see it that way, okay? And then we can talk about the equation a little bit more, okay? One of the things actually that I want to demonstrate with this is how there's a thing you can hear that you won't be able to see that I think is kind of cool, okay? All right, so anyhow, I hooked up the sound because we're now going to start making sound, okay? And let me call this now, I'll call this chaos2.maxpatch, okay? And let me go in and let's, right here, instead of printing values, let's sonify the values, okay? And I'm going to do that by adding some stuff up here for a wavetable. I'm going to say the amp is going to be equal to 20,000, say 15,000. That's probably a good number, okay? And we're going to create a little amp envelope, amp n equals make table, line, 1,000, 0, 50, 1, 100, 0, okay? So it'll just fade up and fade down, okay? 50% of the way through it'll be faded up to 1, 100% will be faded back down, okay? And duration. Let's set a duration of each note to be equal to 0.1, okay? So it'll be long, they'll be kind of short notes, but they'll be long enough for us to hear them, okay? And now let's go down here, and we have this X, okay? So I want to make sure that I'm doing this, okay? We're going to say ST equals 0, because now we're going to have a start time. And we're going to put in a wavetable. Wavetable. And this time I remember what the table. Start is start. Duration is dur, okay? Amplitude is amp times amp end, okay? And now we need to choose a pitch. Well, we've got this value of x that's between 0 and 1. How do we turn that into a salient pitch? Well, a really quick and dirty way to do that would just be simply to multiply it by 1,000. Because then it'll go between 0 and 1,000 hertz, okay? And remember, middle C is about 250 hertz. The C above that is about 500 hertz, you know. This will be kind of a nice area for us to hear these sounds. So this is the essence of data sonification, is figuring out how you're going to take one range of a variable and map it to another range, okay? And the other range is 0 to 1,000. Okay, now obviously that's not maybe optimum for humans because we can't actually hear down to 0 hertz, you know? But I'll be honest, we're not going to go there. We're not going to get down to 0 hertz just because I know what we're doing, okay? All right, and then finally, then we put in, oh, we say freq equals that. We put in our frequency here, okay? Let's put it out in the middle. We don't need anything else. We'll just use sine wave. And we're ready to sonify some data, guys. Okay, oh, one more thing. I forgot. We have to say start equals start. And I'm going to do something kind of clever here. I'm going to do dur divided by 2 so that each note will overlap slightly, okay? As one note is fading down, the other one will fade up because it's going to actually start halfway through the duration of the note, okay? So let's close this off, okay? And now we're ready to go. Let's bring this back down to 2. All right. Let's turn this on, set this, and now we should hear some sound. Okay. Oops, I went a little bit. Okay, so remember I said about 3 was when we started getting 2 values? So there we come up to 3. Then you get the 2 values. And the place where it starts splitting into more than 2 values is at 3.45. Okay. There you go. Okay. And now splitting into 4 values. And now we keep going, and it'll go to, oh god damn it. Sorry, I didn't mean to say that. Edit that out, okay? I never did say that. How did I say that? It's been a long day. Okay, let's do this. Okay. Then we go to chaos. That's cool. I think it's amazing. Yeah, that just boggles my mind. Okay. So, hey, we've actually solidified some data, everybody. Yay! Okay. Now, yeah, we got time. This class, if we don't get through everything today, I've got enough flexibility. We're going to finish it up next time too. The next big thing is to visualize this and graph it. Okay. And now we're going to have to kind of go back to the beginning. You know, already I've shown you like a lot of, you know, how you make RTcmix kind of work and everything like this. Now I need to show you how the graphic stuff works. Okay. So let's get rid of MaxMS2 because we're not going to be using that for a while. And we're going to start up this program called processing. And again, the links for it are in week 1. You can download it and, you know, get it to run. This was a program that was created by Ben Fry, and well, you can read that later. But it was designed, their intention, there are 2 guys that were working out of the NYU in the ITP program, and they wanted to create, or maybe it's MIT, I can't remember. I should just stop saying this. Let me get a drink of water. I'm thirsty. My sister always gets mad at me when I use curse words. So, Brenda, if you're watching this, sorry. You know me. I don't. You know. Yeah. Okay. Processing was designed for artists. They wanted to make it as simple as possible to create a fairly robust graphics environment for artists to use. I'm going to start processing. I'm going to show you some very, very basic stuff. Okay. Here we go. And there's a lot of tutorials and stuff online that you can get. Okay. Ben Fry and Casey reads, yeah. Right. I forgot. Oh, yeah, it was MIT. Yeah, okay. I think Ben started working for NYU, though.
What was originally UCLA?
No. No, this was East Coast. Seems to be taking its time. Oh, there we go. Okay, now, the essence of processing are these things called sketches. Let me get rid of this. Okay. Are these things called sketches, okay? And sketches, basically, this is like when you double-click on the RTcmix object, this is where we type the processing code, okay? And in the RTcmix object, when it prints out into that max window when we were printing the values, this will be printed down here. That's what they call their console window is, okay? Now, first thing I'm going to do is I'm going to save it not as sketch 22023A, but I'm going to give it actually a name and a place that I know where it is. So I'll say save. Oh, actually, and I'm going to go to data signification, week 3. And what do I call this one? I'll call this, okay, chaos sketch 1, okay? Actually, I'm not going to need to do any chaos with this. I'll just call this sketch 1, okay? All right.
Question, are you intentionally using processing 3 instead of 4?
Yes, because I have an old operating system.
Oh,
Yeah.
It's okay to use 4?
Yep. In fact, it's preferred. I started to use 4, and it said you have an old operating system. You can't use 4. I thought, well, I'll use 3. Okay, and that's just because I don't want to upgrade. You know, I'm just angry with Apple and such as like, yeah, one of these days I'm going to have to. This poor machine has been giving me a few weirdnesses lately, and I'm kind of concerned about it. So.
You need to buy a Windows. I'm selling one.
Are you? I already have a Windows. Oh, I got a real sweet Windows one too. It's a gamer's Windows.
Oh, nice.
I'll bring it in someday. Don't worry. All right. Now, in processing, there's basically two things that you want to do. You want to set up what you're going to do, then you want to draw. And in fact, there's two functions that you declare, okay? And this is where things are going to be. Can you guys see that okay? Do you want me to make the font bigger? Yeah, I think I will. Okay, hold on a minute. Preferences. Font size, let's make that be 14. Console, make that be 14 too, okay? Okay, so what I'm going to do, what I just did was define a function. Now, notice it looks a lot like that for loop in RTcmix. This is a little bit different. First of all, processing, you do have to say what the type of something is. And if the something doesn't have a type, it's void. So we're declaring a function called setup that doesn't have a type. And the parentheses are where you would put any parameters if you had any. But we're just setting it up, and we're not going to put any parameters there. And then you define the function within those curly braces, what the function does. And what we're going to do with this setup function is we're going to set the size of our sketch. And we'll just make it be, say, 500 by 700. Okay? And in processing, you do have to use a semicolon at the end. Okay? Well, what are these? These are pixels. Okay, so this sketch that we're going to do is going to be 500 by 700 pixels. Okay? And in fact, we can see it right here and now. We're going to do the draw function later, but we can actually see what this looks like by pressing the run button. And it will execute that setup, and we will see a window appear that's 500 by 700 pixels. It didn't appear. Oh, there it is, way down there. There it is. Yeah, it was hiding from me. Okay, so that's 500 on the x-axis and 700 on the y-axis. Cool. All right, so this is the thing that we're going to like draw into, okay? But you know what? I'm actually going to make it be 700 by 500. Actually, I'm going to make it be 500 by 300. 500 by 300. Okay? So let me say that. Now if we run it, you'll see it's a bit more rectangular. There it goes. Right. Oh, that's 500. I didn't type it right. Oh, forget about it. Okay, just take my word. We're going to use 500 by 300. Okay, all right. The next thing we want to do, though, is draw into it. So we need to declare a function called draw. Void draw. And it looks exactly the same as setup with these curly braces and everything, except it's not called setup, it's called draw, okay? And draw is actually called over and over and over again by processing, because that's how you can animate stuff, that's how you can add new things to a sketch that you're doing, okay? But once you tell it to do something, it'll do it, okay? So what we want it to do is to create a point. And we're going to give it an x coordinate and a y coordinate for the point. So let's make it be maybe right in the middle. So half of 500 will be 250, and half of 300 will be 150, okay? Now, you may be wondering, how did I know this is called point? Well, there's a lot of good tutorials about processing, but the thing that's really easy is to look up their reference, okay? And this comes when you download processing. These are all the different things that processing can do. We're not going to use but maybe 1% of them. Because, I mean, there's things like 3D stuff and everything like this. And the thing that I looked for was a 2D primitive. And I found point, okay? And this shows you examples of what happens with different values for point, okay? Point takes two parameters, the x parameter and the y parameter, okay? So let's close this off, and let's go back to my processing, and let's run this and see our little point. Are you ready? Oh, I forgot to stop it. Yeah. I always forget to stop it, okay? So I'm going to hit run. Here it comes. Can you see our point? That's exactly 1 pixel. of the screen, right there. Now you may be thinking,
Thought it was a piece of dirt.
I know, actually, I read this several times before I realized, oh, it's a pixel, you know. You may be thinking this may not be optimum for plotting out our data because we can't really see it, okay? Well, here's what you can do. If you look, again, I'm not going to bring up that whole reference and everything like this, but there's a thing that you can use, an attribute called stroke weight. And it takes a single parameter, and that parameter is how many pixels wide do you want to make this. So let's try 10 pixels, okay? Now we run it. Oh, I forgot to stop it, okay? We run it again, and now we'll get a big, nice, fat block in the middle, okay? Now, to be honest, that's going to be a little bit too fat, because we're going to be drawing a graph of these, you know, when we start actually doing the stuff from the chaos equation, okay? And in fact, after experimenting with it, I found out that it's probably best as 2, okay? It's still pretty small, but it gives you a pretty good, better look at it, okay? So, there, okay? So that's what we're going to use, all right? So let's turn off our sketch. All right, now, the tricky part, and this is where it's going to look dense, but the good news is you don't really have to fully understand what's going on, just use it, okay? How do we get the data from MaxMSP into processing? Well, we're going to use the power of computer networks to do that, okay? And you're going to use a special library that allows you to send and receive information using an internet port on your computer into processing, okay? And you're going to have to get that library, all right? How's my phone going to work here? Okay. You're going to go to Sketch, and you're going to go to Import Library, okay? Even all that stuff that I showed you on that one page, that was just like a small amount of what you can do with processing. People have created these libraries, okay? And we're going to add a library, all right? And the library you're going to do is you're going to go down here to one that's called OSCP5, okay? And Open Sound Control Implementation, okay? What you're going to do is you're going to click on that and then hit Install, and it does it for you, okay? Tell you what, I'll write this up when I put on the class webpage, if that's going to be helpful for people, all right? Okay? Once it's installed, you can now use it. Well, what is OSC? I'm not going to go into too much detail. We actually had a class where I covered this extensively about a year ago. Maybe I'll put in a link for that. Open Sound Control is a system, is a protocol that was developed at the University of California, Berkeley, that allows you to send stuff over basically computer networks, okay? And you do it using this thing called an internet port, and that's all you really need to know about it right now, okay? If you want to learn more, it's really kind of a rich area, okay? But I've already done mine, okay? But how do I get it set up so that it can receive this data from MaxMSP? Well, the first thing I have to do is import that library. So I'm going to say OSC p5.star, which means, oh gosh darn, not p%, p5, okay? That means bring in everything. Oh, not import. Boy, I'm just like batting 1,000 tonight. Okay, import. That means bring in everything from this OSC p5 library. You know, if we knew exactly what we wanted, we could specify that, but we don't care. We're just going to bring everything in here, okay? And then we're going to declare, like I said, in processing, you can declare floating point variables like x, or you can declare integer variables like y, you know, things like that. We're going to declare a very special kind of variable that's going to be called an OSC p5 variable. Okay? This means that I have this variable, oops, I want to call it, I want to verify what I do. Okay? Notice these are different. The capitalization makes a difference, okay? This is a type declarer for that variable. That's actually a variable now, okay? and that has certain attributes that we're going to use, okay? So this is saying, all right, I have this variable, and it's going to be a variable that gives me access to that whole library, okay? Well, what does that do? Well, what it does is it allows us in the setup to say OSC P5 equals new OSC P5 this. Sorry guys. Damn, what is going on? It's my family. Yeah, my son is in the hospital in Finland. It's okay. It turns out he's had this heck of gallstones, which is relatively simple and easy to take care of, although it's not much fun to go through. Have you had?
Yeah, my dad has.
Oh yeah, no, it's not good. Yeah, we've had it in my family, so yeah, the laparoscopic thing was one. So I just want to make sure it's freaking out. Okay, back to this. Okay. All right. Well, what the heck is going on here? Well, remember I said that this variable was that type? Well, this is saying, well, yeah, it's that type, and these are the parameters. This is just some weird thing that you just put in. You know, it refers to the actual sort of processing object itself. This is the internet port number that you're going to use to communicate. So in MaxMSP, I'm going to use that same number, and that's the way I'm going to get the data to come over to this guy, okay? This can be anything. Anything, I can't remember what there's a lower bound that you can't go below, and I think it's 2,000, because there's a bunch of stuff reserved already for internet ports. There's ports for like web pages, you know, that's coming in on a specific port. There's port for like mail. That comes in on a specific port, you know? And those are reserved. They were reserved like eons ago, okay? But 7878, I just made that number up, you know? And you can go up to like, you know, 20,000, I think, or even higher, you know? Chances are you're not, there's a very slight chance that you might collide with another service that's running on your computer that's using these ports. The chances are very low. It's only happened to me once in my lifetime. And 7878 just seems like a nice lucky number to me, so.
There's also a list online of like all of the ports and like which programs use which ones, and so you can like, avoid them.
Mine was more insidious. It was a program that I had actually written, and I forgot it was still running. So yeah. Anyhow, okay. So that's cool. Oh my gosh. You know what? I'm going to bring up my class page here because I don't want to have to type this out because we will be here for the rest of the class otherwise, okay?
I have a quick.
Yes, fire away.
So I installed OSCP5,
Yep.
and I just need to get it installed inside the sketchbook folder. Did you already show us that?
You should just hit the install button and it should just work.
My code will run, so...
Mine didn't at first, but then I just closed it.
Oh, you have to restart processing.
Oh.
That's, yeah, sorry, yeah. Yeah, whenever you add new stuff to a program, a lot of times you have to restart it too. Try that, okay. All right, what did I just do? Well, down here in the down here below the draw program, I'm going to create one more function. And this function is kind of crazy. All I did was cut and paste. That's it. Okay, because like I said, I didn't want to have to type that out. All right. Now, what this is this is declaring a function called OSC event. And it's going to give you something, okay? And this message is going to have certain parameters associated with it. And notice that it's assigning a value to two variables here, x and y, and they're underlined with red because I haven't declared them yet. I'm going to declare them up here. I'm going to say float x. I'm going to say float y. Because they are indeed floating point variables, okay? And notice that my little red underscore has disappeared. That means they're declared. Now, there's something here. I'm declaring these variables up here. Well, you know, hey, I'm only going to use them in the draw function. Why don't I declare the variables there? if I did, those variables would only be good inside that draw function. When I declare them up here, they're good through the whole sketch. Okay, that's called scoping, by the way. Okay, so.
Brad, do you think you could put the lower part, the message that starts at void and then OSC event, could you drop that in the chat here in Zoom?
Oh, sure. Also, this is going to be
It is
linked on my
also-
page too. Okay, yeah, I will drop it in the chat real quick. Okay.
Okay, cool.
Yeah, because I don't. Yeah, you guys don't want to have to type
Where
this
was
in.
this on your page?
What's this?
Where was this on your page?
It's not on there yet. It'll be on there by this weekend. Okay. Yeah, just in time. Okay. Okay. Chat. Where do I get a chat? Chat. Okay. Oh, I don't want to see my chat preferences. What's on my mind? Is that what? I don't want to put my personal space there. What the heck? This is not the chat I want. Hey, does anybody know how I get the chat window up? Oh, it's probably up under here under window. View? Show chat. There we go. That's it. Okay, guys ready? There it comes. All right. Okay. All right. So this is now set up. We're going to be able to, if we set up MaxMSP correctly, we're going to be able to get these messages, and we will get the value for a variable x and a variable y. Okay. And let's just go ahead and for the fun of it, let's not use it even. Let's just print them out so we can see that this is working. Okay. So under draw, here's what we'll do to check it out. We'll just, instead of making the point B in the middle, let's make the point B at x and y. So that means that if we can set up our MaxMSP program to send over values, we should be able to get points to go along the screen, okay? So here we go. Now I'm still calling this sketch 1. I should probably have called this sketch 2 at some point. So let me do that now, okay? Well, I'll call this sketch OSC, okay? OSC1, okay? I'll go back and kind of clean these up. All right, so now we're going to go back to MaxMSP world, okay? And we're going to set it up so that, now, the good news is that this is ridiculously easy, okay? I'm going to put this guy away for now because we're not going to use all that fancy stuff, okay? We'll get him back later, okay? But I'm going to start the new MaxMSP thing, okay? And I'm going to say send localhost. Okay. Now, get a loading point number here. Loading point number there. All right. And we're going to prepend something to these before we send them into that UDP set. I'm going to go back to my processing. And notice it's checking for a pattern that says /xval or /yval. This is what OSC does. You can tag your data. And what that means is that I can go out here, and just like with RTcmix, I can say prepend /xval. And over here, I'll do prepend /yval. Okay? You guys need to see this printed out to see what it would look like. Basically, it would say /xval and then the number. Okay, or this one would say /yval and then the number. Okay, that will tell processing if I'm getting an xval or a yval. The processing is going to look for those particular tags on it. And I've attached those tags here. So now, if I put this here, I put this here, now I'll be able to send x values and y values over there. Okay? Let's save this. We'll call this, okay, send OSC1. Okay? Now let's go over to processing, and with any luck, again, we've got it all set up to print out that x and y. We'll start this up. Okay, there comes my sketch. Now let's go over to Max NSP land and watch what happens when I send this. Oh, look. It's at the very top. That's because it was up at 0.0. Look. Whoa. I've invented an Etch-a-Sketch. Okay. So I can send these around and, you know, do all kinds of fun things with them. Yeah. Unfortunately, I can't do two at the same time, so all of my lines have to be straight. Okay. Yay, team. Yay, team. Yay. Okay. Now, I want you to notice something, though. Okay. Something we're going to have to, like, think about when we actually go to, like, plot stuff out. Okay. Let me move this over a little bit. Okay. Notice that this Y vowel, okay, this is this thing here. As it gets towards 0, it goes up. And as it gets towards 300, which is why I said it goes down. Now, this is the opposite of every graph that we've ever learned as human beings, where the Y and X 0, 0 point is down in the lower left-hand corner. In computer graphics, it's up in the upper left-hand corner. This has to do with the original cathode ray tube technology and the way they scanned the lines. They start at the top and scan down. And then when they developed things called rasters, which it would read, they continued to do that kind of scanning. And basically, they just kept it. So that every graphics program that I know of has the 0, 0 point up there. We're not going to use that. We're going to flip our data. That's part of what we're going to do with this mapping stuff. And we're going to, like, you know, turn it around like that. Okay? But basically, we've got this stuff happening. Okay? All right. Yeah, let me stop. How are you all holding up? Are you doing okay? Is this an oversaturation with information yet? Yeah, Steve, I'm going to ask you because yeah.
Well, I have to think about it.
Okay.
I think it's okay.
Okay. Okay. We're almost there. I mean, you know, basically we've got the graphing and we've got the sound. The thing is now to try to connect the two. Okay. And in fact, let's just do that. Okay. Okay. Let me think about. Right. Let's go back now to our Max NSP, and let's bring up that old Chaos 2 thing that we had. Open Capture. Okay. And let's now call this. This is going to be the last one we're going to do tonight. Okay. I'm going to call this Chaos 3 OSC. Okay. All right. Now, what we're going to do is go back. I probably shut that down a little bit too soon. Let's look at this guy. Okay. We're going to take this out of here and put it in that. Okay. No, I need to copy and paste it. Oh, what am I doing here? This is getting weird. Hold on. I don't understand what's going on. Hey, Nicola? Oh, there we go. Never mind. I was getting like that weird line in Max MSP because I was like above the thing. Okay, we have to copy and paste it. Okay, let's go here. Paste. Send that over there. Okay. All right. Now, let's go back and instead of X val and Y val, let's have an X val. Let's call X. We'll have a Y val. Let me look this up. We're going to have a Y vowel and an R vowel, okay? Okay. Why did I change that? Well, the R vowel is obvious. That's going to be the value of R, okay? Now, instead of X vowel, even though we're calculating X in here, I'm going to call it a Y vowel because that's going to be the value of the Y axis that we're going to use to plot, okay? And that one, we're going to send out of RTcmix. Okay? Yeah, hold on a minute. I need to look at this. Okay. And we're going to use another RTcmix function here, okay? We're sending out a max value, but now we're also going to send out a max message. We're going to send it out at time st after it's calculated all this stuff. And the message we're going to send it is x. What's this? Well, this sends out a bang out of that port. So that sends bangs out of here. This will send values at a particular time out of that port. Okay? In fact, let's so after it calculates all these x's, I'm just going to choose one of them, and I'm going to send it out with that max message. I think. Actually, I think I want to do this up. No, I'm going to do it here. Hi, are you holding up okay?
Yeah.
Okay, good. I just want to make sure that we're not like saturating your brain.
I've never seen anything like this in my entire life.
Don't worry, you'll become an expert in no time. Seriously, guys, try some of this stuff out. If you're having serious problems with it, contact Nicola or myself, and we can sit down and try to explain things a bit more. Yeah. Okay. All right. Anyhow, so we're going to send this out, and again, there's going to be redundancy. We're going to do a lot of this again next class, but with a different equation. So you'll see some of the stuff kind of, happening over and over again, kind of fading in. Okay, so we're going to send out this message at that time. We're going to give it one of our x values, and that's what we're going to use to plot, okay? So let's go up here. Now, here's a problem. We have both bangs and floating point numbers coming out of that. How do we separate them out? Well, we do it like this, okay? Fortunately, MaxMST has a way to do that. It has an object called root, and you can say root floating point number is out of one of your outputs, and root bangs out of the other one. So we put that here, and notice here it says, ooh, well, if this input matches a float, it'll be out of there. So we'll put that into our y value. And then that says, if it's a bang, come out of there. So we'll say, okay, we'll take this one and put it up to our bang. Then the other thing we need to do is we're going to take this value and put that into our R value. So now, via the magic of this UDP send, our processing sketch is going to get something that's labeled /y val and something labeled /r val. Those are the two numbers we need to plot the plot, okay? So our max patch is done. Let's now go back to our processing sketch. And let's modify it. Okay, now I'm going to call this now something new. I'm going to say save as, and I'll call this processing sketch OSC2, okay? All right, and let's go down here, and first of all, we're going to get /y val, and we're going to get /r val, okay? And that's going to give me my variables x and y, okay? X is going to contain something that's going from 0 to 1. Y is going to contain something, and I'm just going to say right now, the useful range is going to be 2 to 4, or 3.999, okay? All right. Now, we need to change those ranges into a range that reflects the size of our screen that we're doing, okay? Let's deal with the y value first, okay? Let me go back up here. And to do that, we're going to say float y val equals. Now we got this y, and it goes from 0 to 1, okay? We want it to go from 0 to the height of the screen. And instead of having to go back up here and go, oh, I remember it was 300, you can actually use the word height here. And then if we change this size, this will still be cool. Okay, so this is just like what we did with the going to 1,000 in the hertz. This will now go from 0 to 300 pixels. However, there's a problem. Remember, because it's flipped, I want to go the opposite direction. Turns out that's easy to correct. All I have to do is this. Okay, so now when y is 0, it'll actually be 1. And when y is 1, it'll actually be 0. So that's basically just flipping that thing over so that we don't have it going down, we have it going up. Okay, so that part's done. Now, the x value is a little bit trickier. Okay, let me put here, we're going to say float x val equals, well, we've got this number r coming in, right? And that's going to be between 2 and 4. We want to turn it to going between 0 and 500. Again, this is the essence of data plotting, is this mapping from one scale to another. Well, the first thing I'm going to do with R is I'm going to subtract 2 from it, okay? Because that will then take it from being between 2 and 4 to being between 0 and 2. So I've got one side of it already set, the 0 side, okay? Now, if I divide that by 2.0, then instead of going from 0 to 2, it'll go from 0 to 1. Final thing to do is to take that because
Brad,
this
do you
converts
think
the 2 to 4 to between 0 and 1. Then we just multiply it by the width, so it'll be between 0 and 500. Yes, Steve, question?
Brad, do you think that it would be possible to put the code from processing in the chat again? I think then it's easier to follow for everyone online because we can just drop it into our own.
Okay, you mean the whole thing?
Yeah.
Okay, let me finish it off. It's not done yet. Okay?
Okay.
Or do you want me to put it in now and you can modify it?
No, I think once you're done.
Okay. All right, now, I've got a problem here. I no longer have an x, I have an r. Right. This is now x val. This is now y val. Okay, I'm kind of losing it. You know, I'm getting a little bit weird too. I'm going to probably go over this again next time because this is making sense. But essentially, we're done here. I just wanted to show you what it looked like. Okay. I'll be honest. I don't think I did a good job of explaining that very well. Okay. But I'll put the code up and you can like take a look at it. You know, and yeah, I'm going to go through this again next time because this isn't good. Okay, so let me drop this in the chat for those who are chatting. Let's go here to chat. Okay, there you go. All right. Now, with any luck, this monstrosity of a max patch will communicate with this monstrosity of a OSC sketch, and we will both hear the sound and watch it being plotted at the same time. Okay, so here we go. Go to sketch. Turn this on. Turn that on. Set this guy to 2.0. And hit bang. Now, here's what happens. That's not right, is it? Okay. Like I said, I felt like I was losing it. Well, obviously I did because I didn't do this right.
Semicolon maybe?
Could be. I waste my life with semicolons. Okay. R val, R prefix slash R val. Okay. R is a floating point number. R val minus 2, R minus 2, that's going to be 0 to 1, divided by 2, that's going to be 0 to 2. Okay, so that's all. Oh, huh. No, that's all like good. That should have worked.
Oh, you have two separate things declaring a number in X.
What's that?
Like you have the 2 at the top and then you have the 272.
Right. Well, this is basically.
Oh, they're tied.
Yeah. Oh.
But if you're sending 0.5 as the X value forever.
Yeah. I think.
Or you just
Let me do this. Okay. Maybe I didn't hit the text thing. You know, it could be. Hold on. Let me try this again. Sorry, gang. Oh, it was going kind of well up to this point. Let's try this. Bang. 0. There we go. I forgot to send the 0.5, okay? Okay, now.
That's awesome.
Yeah. So let's watch what happens here. There I go. I'm creeping up, I'm creeping up, I'm creeping up, I'm creeping up. Creeping up, creeping up, creeping up, creeping up. Whoa, I creeped up a little bit too fast. Okay, now, there's a couple things wrong, okay? Well, there's more than a couple things wrong. Okay, first of all, we're only getting one side of this, okay? And that's because I'm only sending out one value from this, okay? And I need to send out more than one value. And the other thing is that we've disconnected the R from when we calculate our X value. And that's why you're getting these things kind of all over the place. It's not a nice clean graph, okay? And I tell you what, I'm not going to fix those now. We're going to fix those next time because, like I said, my brain is shutting down. And if mine is, I can imagine you guys are sitting here just going, oh my God, what have I done? You know? All right. So we're going to call it quits for now. But any questions, the people have at this point that I might be able to answer about such? Is it give me probably until Friday, Saturday, sometime this weekend, I will put up a downloadable thing that will have all this stuff in it, everything we've done tonight, so that you can start taking a look at some of it and see if you can make it go. And I'll put in the links to the stuff on the class webpage. Okay. All right. Anybody from the Zoom? You got any questions or anything? Everybody cool?
No, I would just like to say that the Discord channel is still coming.
Oh, good.
Because I was informed that there was a Discord set up for all classes at CMC, but that didn't seem to have happened already this week. So I'm waiting for that. So next week, I think we will have a Discord channel for our class.
Cool. Okay. Yeah. Nicole, I promised that I'd talk about how the equation kind of worked, but with that graph, I don't want to. I want to make the better graph, okay? Because that's not quite right. It's sort of barely there, but not really. Okay. So we'll hold that off till next time too. All right. Okay. That's it. I'm going to close up my processing. Let me stop my share here and say goodbye to everybody on Zoom. Right? Bye, everybody on Zoom. Okay. See y'all later.